quadratic trinomial now where the leading coefficient is not 1. So here's a warm-up. See if you remember how to do this. The pattern, the factoring pattern, is in the top right corner. So other than that, the only real thing you need to remember is that we're taking the square roots, because a squared is 9x squared in this case. So to get a, we take the square root of both, and we get 3x. B squared is 121. Again, take the square root, so b is 11. We use our factoring pattern here, and we set it up. We say a plus and minus b. Now let's look at factoring by grouping. And always with factoring, of course, you need to know how to actually factor it, but knowing when to factor it is just as important. So when do we factor by grouping? It's when you have 4 terms with no GCF, right? Because these 3, they all share a GCF of x, but they don't share anything else, right? These share a GCF of 25, but these factors do not, or those terms, okay? So factoring by grouping, here's how it works. You first take the first 2 terms, you put them over here, then you take your second 2 terms, you write them over there. We are separating the first 2 from the last. Now we factor out the GCF of just these 2 terms. So we factor out the x squared there. So here we factored that part of it. Now we need to find the GCF of these. That negative 25, factor that out, and here we are. Now, this is all great. We have factors, but it's still separated, and we want to put everything together, right? Well, if you were to multiply this out, wouldn't you say that you're multiplying x squared times x plus 2? And you're multiplying negative 25 times x plus 2? So this is really, really key, okay? When factoring by grouping, what you want, what you need, is the same thing inside the parentheses, okay? And here's the logic. If x squared and negative 25 are multiplying with x plus 2, can't we just rewrite it like this? So in other words, you're taking what's on the outside and grouping it together. And then you're taking what's on the inside and grouping it together, just writing it one time. Okay, you're not writing x plus 2 twice. Now, take a look at what we have here at the bottom. Do you see anything familiar right here? Hopefully you notice that there's a difference of squares highlighted in yellow, isn't there? So this is your first time seeing at this unit that you can and will have more than one factoring pattern in one problem. Sometimes there's 2, sometimes there might even be 3. There could be more than that, but that's not common. So you have your difference of squares. The x plus 2, hopefully you can see that that is as simple as it can be. There's no pattern there, so you just write x plus 2. And again, to factor our difference of squares, we did this before, you take the square root of the first term and the square root of the second, and then you plug them in. X, 5, 5, and this should be a plus, minus. There are no more patterns here. Ultimately, keep looking, keep searching. Are there more patterns going on? Because if there are, you need to keep going and continue factoring. Now, notice there's 3 factors here, right? 1, 2, 3. We're not finding solutions yet, but we factor to ultimately find solutions to solve for x. In this case, there will be 3 solutions for x because there's 3 factors, and also because this was a cubic polynomial. So this is pretty helpful. If you have x cubed as your leading coefficient and a cubic polynomial here, you're going to have 3 factors at the end and 3 solutions. Now go ahead and try to factor this one for yourself. Hopefully you notice there are 4 terms with no GCF. So we factor by grouping. These share an x, but that's it. These share a 2, but that's it. And do we have the same thing in the parentheses? Absolutely. Okay, so write what's on the outside in parentheses together, and then what's on the inside once. No other patterns? That's it. Now, what about factoring a quadratic with a leading coefficient greater than 1? Do you know why this is a quadratic? Hopefully you know it's because there's the x squared is the leading term. Okay, if the leading term is x squared, it's a quadratic. But before, we looked at quadratics like this, didn't we? Do you remember how to factor those? So we use the x method, which you can see we're going to use again. But because the leading coefficient in this case is 3, we also need to factor by grouping. So it's going to be solved differently. But if the leading term has a power of 2, that means we can start by identifying A, B, and C. Remember, these never include variables. Never, ever, ever. Okay? And yes, we will use the x method. We put A times C on top, so 3 times 20, and B on bottom. Now we look for factors of 60, right? 3 times 20, 6 times 10, but you want factors that multiply to give you the top term or top number and add to give you the bottom. Well, that's going to be 6 and 10. Before, with a leading coefficient of 1, you would go ahead and you'd use your pattern and you just write this out. And you go x plus 6, x plus 10, and you're done. That's not what we're doing in this scenario, though. Okay? What we're doing is we're rewriting 16x, and you'll see why in a second. So the reason we use the x method is so instead of writing 16x, we can write 6x plus 10x plus 20. Because isn't 6 plus 10, 6x plus 10x, 16x? So we can do that, absolutely. And you might also be wondering, well, I know numbers that add to 16x. Couldn't I just pick 2x plus 14x? No, because that's not going to work out when you're factoring by grouping. And notice, doing this set us up for success because we have 4 terms with no GCF, meaning we can factor by grouping. So let's do it. You get a GCF of the first 2 of 3x, GCF of the second 2 of 10, and the question always is, did I get the same thing in the parentheses? Yes, I did. So group what's on the outside, group what's on the inside, and we're done. Now, you might be wondering, how do I know which number goes where when I'm doing this? It doesn't matter. Let me show you what I mean. Let's say instead we decided to write it like this, where we had 10x first and 6x second. What's the GCF here? X, and then you'd have 3x plus 10. What's the GCF here? 2. You'd have 3x plus 10. So we did that differently than we did below, but look what happens. Group what's on the outside together, group what's on the inside. Same answer, just in a different order. Pretty cool, right? So either way works. So don't worry too much about which number goes where. All right. What do we do first? That's the big question here. Well, if you thought I'm going to identify A, B, and C, that's if the leading term is to the power of 2, meaning it's a quadratic. Well, that's not the case. So that's not the go-to strategy. And then you're thinking, okay, there's not 4 terms, so it's not factored by grouping. What can I do? Well, there is a GCF. Don't forget to always have that tool in your back pocket to look for the GCF. So 2C is the GCF. So we're going to have 36C squared minus 12C plus 1. Let's just double check that that's correct. C times C squared, C cubed minus 24C squared. Yes. Now we're going to really focus on this part, okay? Now we have a quadratic. Leading coefficient is greater than 1, so we need to use the x method again, right? A times C and B. Well, I just can pretty quickly tell in my head that -6 will be the right numbers. They both multiply to 36 and add to -12. So here's what we do. We rewrite what we have. 2C times, what do we get here? We're rewriting the middle term, right? So we get -6x minus 6x plus 1. We rewrote, oh, why did I use x? Probably because we use it all the time. This should be c minus 6c plus 1. We just rewrote that middle term, right? Just like before. Now we can factor by grouping, right? So let's do it. We're going to have a GCF here of 6c, so times 6c minus 1. And so I'm leaving out the 2c for now, okay? Just underline, do whatever, make sure you don't forget that later. And then what do we have over here? Let's see. If I do 6c times, actually, I think they only share a GCF of 1. I think it's going to be -1, actually. So let's see. 6c plus, no, 6c minus 1. There's some tricky stuff going on with the signs, but you experiment and you'll find the right thing. Let's just double check. 6c times 6c does give you 36c squared. 6c times -1 does give you -6c. We did that correctly. The next one, -1 times -6c. Yes, -1 times 1 gives you +1. And we have the same thing in the parentheses. So we did it correctly. Here we go. You had 2c from before, right? Don't forget this guy hanging out. And then we have what's on the outside grouped together and what's on the inside. Notice they're the same thing. So we could write it like that. You could also write it like this. All right. That is the end of our lesson for today. Have a great day, and I'll see you next time.